The lecture Volkswagen Audi Automatictransmission computer common failures. Now we will talk about the common failure of O2E, automatic transmission computer ECU. Look at this picture of the O2E automatic transmission computer. It has many parts the same as the OEM automatic transmission computer we told you before. What I mean by similarity is not that the motherboard is the same, but that it has the same principles, properties, and maintenance methods. Many of them are the same. The O2E automatic transmission computer is a ceramic computer board. When we open the computer board cover, the first thing we see is that all the welding and electronic components are very precise. At the same time, the transmission computer is filled with jelly glue. The role of jelly glue inside the ECU is to dissipate heat, resist earthquakes, and prevent corrosion. When there is a problem with the ECU and it needs to be repaired, it also provides us with settings. There are some obstacles, so when we repaired it, we need to remove the glue. But when removing it, try to remove the glue partially, not completely, please. If all the glue is removed, the computer will be at risk of damage. Please take a look at the small gold wire next to the CPU inside the computer. It is easy to damage the gold wire next to the CPU through glue removal. Therefore, during the maintenance and operation process, try to remove the glue partially. And do not remove all the glue, please. The risk of removing them all and then repairing them is extremely high. Next, it is about no communication failure today. We will find 3 failure points for you. We will divide it into 3 videos to share. Because the video is relatively long, I am afraid that someone will be confused during the measurement and learning process. There is no communication failure. Please see the notes for the first fault point. There is a 17 ohms resistor connected between the red dots. Use a multimeter to measure. The positive value should be 17 ohms. The 17 ohms resistor is in the red box. Let's deal with this paragraph first. We mark the 2 red dots. The 2 red dots were measured with a multimeter to be. If it is not 17 ohms, it means that either the resistor in the small red box is damaged, or there is an open circuit between the 2 sides of resistor and the resistor, resulting in the measured resistance of the 2 red dots being infinite. Let us look at paragraph 2. If the measured resistance value is infinite, it means the resistor is burned out, or the connecting wires on both sides of the resistor and the resistor connection points are disconnected. You can clearly see that between the 2 red dots, the measurement is 17 ohm. If it is not 17 ohm, it is an infinite resistance. Then let's take a look at the second picture. This is a picture I enlarged for everyone. Why are there 2 boxes? There is a yellow box and a red box. The yellow box is circled to the smallest range, making it easier for everyone to find the location of the failure point. What about the little red box? It is the location of the resistor and where the failure point occurs. Please take a look at the 2 red dots. That is, the 2 red circles. are measured with a multimeter to be 17 ohms. In order to find the failure point, we use a pen to find its location. In the second line, we draw the position of the resistor. The failure point is the 17 ohms resistor. Either the 17 ohms resistor is burned, or the two sides of 17 ohms resistor. One side is disconnected and corroded, meaning a broken circuit. As for the method, we can measure the resistance. If the resistance is 17 ohms, then we can use our wire to connect and weld on both sides of the resistor. For example, as you can see in this picture, it has been repaired. Please see that there is a line connected to the position where I drew the stroke, which means that at this position, the resistor and the edge line are disconnected. Then we use a small wire to solder the resistor and the connecting wire. After we weld it, we will measure it. The resistance between the two red dots is normal, 17 ohms, and the problem is solved. Please look at this picture, which is also the last picture. Two red arrows and a yellow arrow. The location pointed by the two yellow arrows is the location where the failure occurred. The red arrow in the middle points to the resistor, which is 17 ohms. The way we want to deal with the failure point, we need to deal with this on the yellow arrow. Weld the edge of the resistor and the connecting wire, and the failure can be solved. After soldering, measure 17 ohms between the two red dots. The first case of no communication failure, we have found, welded, and processed at the same time. Now for the actual measurements. Please look carefully. This is the location found. I just talked about theory. Let us talk about practice now. Get the O2E automatic transmission computer and find the fault point, please. Let's narrow the scope first. All communications are based on the CAN line module. Find two red dots, please. This is red point 1, then find red point 2. This is red point 2. The resistance measured at the two red points is 17 ohms. If you look at it again, the 17 ohms resistor is at this location. The failure point we are talking about this time is also on the 17 ohms resistor. We talked about two problems. First, the 17 ohms resistor was burned and damaged, resulting in no series connection between the two red dots, and the measured value was infinite. The second way of damage is that the two ends of the resistor and the lines connected to the two ends of the resistor are corroded or open-circuited, resulting in the inability to connect in series. Then the two-point measurements are also infinite. Now we will measure the two points and find the points measured by the two red points. Turn on the multimeter first. The multimeter can be set to 400 ohms or on-off mode. Because the resistance is small, you can use on-off mode or 400 ohms. We set to 400 ohms and then find the measurement points. Two red dots. Measure and look at the multimeter. The value is 15 ohms. That means there is an error. Our resistance is 17 ohms, which means that the resistance and the connecting line are normal. If the measured number is infinite, it means that the resistor is broken, or one of the two lines which is connected to the resistor is open circuit. For example, this transmission ECU. Please look at it. We have repaired it before. This line was open circuit, so we added a line and then welded it. So let's take notes now and find the location of the resistor. Find the 17 ohms resistor. Draw a red frame with a pen. It is 17 ohms, and then mark it with 2 red dots. If the measured resistance value is infinite, it means that one of the two connecting lines is open circuited. Most of them are the line on the right, which is a long line and is soldered at the edge of the resistor. If you find that this line is open to soldering, you can use a wallpaper blade or a knife to draw a line between the resistor and the line, and then add soldering to solve the problem. Therefore, for the first failure point, the maintenance method without communication has been implemented and explained to everyone. Please be very careful when welding during maintenance. Be careful. Please take notes. Thank you.